Check 1, 2, 3. Check 1, 2, 3. Good evening, everybody. Well, vibration in tubes. Some important essay questions. 1990 A levels. 1990 A levels. Vibration in tubes. Okay. Explain what is meant by resonance. Now, what is resonance? When the external force frequency is equal to the natural frequency, large scale amplitude vibrations take place. When large scale amplitude vibrations take place, that is known as what? Resonance. Okay. You must write that in words. Next one, a vibrating tuning fork is held over a narrow tube containing variable amounts of water. It is found to give resonance at consecutive lengths 0.359 and 1.079. In a separate experiment, tuning fork gives beats of 4 Hz sounded with a second tuning fork of frequency 234 Hz. Right. So here you go, the tube. Water is filled here. This length is 0.359 meters. 0.35 meters. Tuning fork is there. Frequency F1. Again, water filled. Air column length 1.079 meters. 079 meters. Frequency F1. So we don't know the harmonic number. Anybody looking at this can say, you can't say first and third. You can't say third and fifth. We don't know. So what you can do is you can write a general relationship here. You can write a general relationship here. The relationship is going to be what? Frequency F1 is N divided by 4 times 0.359 plus 1 in correction. Also, F1 is equal to N2 times V. 4 times 1.079 plus in correction. Equation number 2. Equation number 2. So 2 possible equations. Then they're asking you, this tuning fork, when sounded together with another tuning fork, produces 234 Hz. The second tuning fork also gives resonance for the above mentioned air columns, but lengths are slightly increased. Carefully. Now we are using a second tuning fork. What do you mean by second tuning fork? Note this carefully. I'm using a second tuning fork, that is 234 Hz. At this situation, the vibrating length is more than 0.359. Second situation, the vibrating length here is more than 1.079 meters. How can the vibrating length increase? Vibrating length can increase only if the frequency decreases. So your logic will tell you very simply, very simply, why is the vibrating length increasing? Because the frequency is less. 234 Hz is lesser than F1. From this quickly you can find F1 minus 234 is going to be 4 Hz. F1 is equal to 238 Hz, right? Unknown frequency found. Very simple. So vibrating length column increases only if the frequency is less. So this frequency here, 234 Hz, is less than F1. From there, you can simplify, get your relationship. That's going to be 238 Hz. 238 hertz, right? What are they asking you? Find the end correction and the speed of sound in air, right? Done. So now we can go back to this equation. Now we can go back to this equation. So if you go back to the equation, very carefully look. First of all, we don't know the harmonic numbers. So let's divide all. 1 and 2 are equal. 1 and 2 are equal. 1 and 2 are equal. We can write like this. N1V 4 times 0.359 plus N correction. N2V 4 times 1.079 plus N correction. V and V cancel off. 4 and 4 cancel off. N1 divided by N2 is 0.359 plus N correction. Divided by 1.079 plus N correction. If you ignore the N correction, N1 divided by N2 is approximately 0.359 divided by 1.079. 1.079. So 359 divided by 1.079. Actually, if you multiply it by 3, 27, 15, 17, 10. These approximately 1:3. 1:3. Therefore, N1 is going to be first harmonic. N1 is going to be first harmonic. N2 is going to be what? Third harmonic. N2 is going to be third harmonic. Right. Once you found this, you can find the N correction easily. Now go back to equation. Go back to your main equation. F1 equal N1V 4 times 0.359 plus N correction. They want the N correction and the speed of sound in air. Divide 0.359 plus N correction. N1 is 1. V divided by 4 times F1. 238. Equation number 3. Also, you can say F1 is equal to N2V 4 times 1.079 plus N correction. 1.079 plus N correction 3 times V divided by 4 times 238. Equation number 4. Equation number 4. Subtract the fourth equation by the third equation. 4 minus 3, 1.079 subtracted 0.359. 0.72. 3 V over 4 times 238 minus V over 4 times 238. 0.72. 2V divided by 4 times 238. 2 times 1, 2 times 2. Cross multiply, V is equal to 2 times 0.72 multiplied by 238. 2 times 0.72 multiplied by 238. So if you want, you can multiply it, get the answer. 144, 2 decimal places, 238. 32, 335, 11. 12, 13, 4. 8, 8, 2. 14, 3. 2 decimal. 342.72. 342.72 meters per second. So what we have done here is very simple. Huh? We don't know the harmonic numbers. If you don't know the harmonic numbers, write the equations, equate it. Ignore the N correction. Approximately you will get. Approximately N1 is first harmonic, N2 is third harmonic. And because it's a closed tube, only odd harmonics are there. Yeah, only odd harmonics are there. And they are telling you this is consecutive, close to each other. Once you simplify it, do the substitution for N1 and N3. Once you finish it there, velocity is 342.72. Now, once you get the velocity, you have to find the n correction. You can substitute to any equation that you want. Let's say you substitute to equation 3. Substitute to equation 3. How much? 238. Sorry. 359 n correction. Substitute to 3. 0.359 plus n correction. 1 times V 342.72 divided by 4 times F. 238. 342. From this, you can find the n correction. 342.72 divided by 4 times 238 minus 0.359. N corrections you will get in meters. N corrections you will get in meters. So once you simplify this, zero point zero zero one. 0.001 meters, that's about 1 millimeter. That's about 1 millimeter, right? So question 1990 A level. 1990 A level, look at this carefully. They are telling you that two closed tubes resonating with the tuning fork, 0.359, 1.079 consecutive. That means first harmonic, third harmonic, fifth harmonic, seventh, ninth, like that, close by. If you sound it with a tuning fork 234 hertz, the vibrating length is a bit longer. Longer vibrating length means lesser frequency. Logic is longer vibrating length means lesser frequency. So 234 is less than F1. And if I sound the two tuning forks, I get a beat frequency 4. So F1 minus 234 is 4. F1 is found 238. I don't know the harmonic number. So this is N1th harmonic. N1th harmonic. This is going to be N second harmonic. In second harmonic. I write two equations. Now, since I don't know the harmonic number, what we do is we can equate it. We can get the ratio. Ignore the n correction. 1:3. 1:3 means here if you simplify it. Here if you simplify it. Here N1 equal first harmonic. N second equal third harmonic. N1 first harmonic, third harmonic consecutive. You might say, sir, why can't you multiply this by 2 and 3? So 2 here means 2 and 6. We don't have even harmonics now out of the picture. If you multiply by 3 and 3, 3 and 9, are they consecutive? No, they are not consecutive. So 1:3. 1, 3. Substitute for the first equation, we have relation. Second equation, we have a relationship. Simultaneous is all. Velocity of sound in air, 342.72. Substitute to any equation, you can find the n correction. 0.001 meter or 1 millimeters. There you go. This is 1990 A level question. 1990 A level question done. 1990 A-level question. Right? Okay. Right. Next is 1993 A-level question. 1993 A-level question. Look at this. Velocity of sound is given by the equation V gamma P over rho square root. V gamma P over rho square root. Identify the symbols given. Show the equation is dimensionally correct. What are the symbols? Gamma, Cp over Cv ratio must write in words. Specific heat capacity at constant volume. Cp over Cv, specific heat capacity at constant pressure divided by specific heat capacity at constant volume. What is P? Pressure of the gas. What is rho? Density of the gas. V is velocity of sound in air. Show that this equation is dimensionally correct. So if you take left-hand side dimensions V, LT minus 1. Right-hand side dimensions, if you take gamma P rho square root. Gamma is dimensionless. Pressure is ml minus 1 T minus 2. Density is ml minus 3 square root. Mm cancel off. L square T minus 2 to the power half. Simplify this. LT minus 1. Left hand side dimensions equal right hand side dimensions. Easily found. Okay. Left hand side dimensions equal right hand side dimensions. Right. Use the above equation and derive a velocity of sound in air in terms of molecular weight and temperature. So that you can do like this. Mass. PV equal M capital R T over molar mass. P equal simple MV RT over molar mass. P equal rho RT over molar mass. P over rho RT over molar mass. So wherever P equal gamma P over rho square root, P over rho is RT over molar mass square root. RT over molar mass square root. Okay. RT over molar mass square root. Okay. Right. Okay. Look at the question now. Two men are standing 209 meters apart. Two men are standing 209 meters apart. Two men are standing 209 meters apart. Both see lightning flashes along the extension of the line joining them. So both are seeing extensions, lightning flashes. Man A hears thunder after 2 seconds. Man B hears thunder after 2.6. So all of you all know lightning must have struck close to A. Time taken here 2 seconds. Time taken here 2.6 seconds. 209 meters. Sound has traveled in 0.6 seconds. So thunder should first go to B and then passing B, A only will go to B. A is heard in 2 seconds, B in 2.6 seconds. That means 209 meters in 0.6 seconds. 2.6, difference is 0.6. Right. If you apply the equation, find the velocity of sound in air. Velocity of sound in air. Distance divided by time 0.6. 2090 over 6. 3 29 you have 4. 50 you have 8. 20 you have 3. 348.3 meters per second. Find the temperature of air. Find the temperature of air. Find the temperature of air. How can you find the temperature of air? Have a look. They are given at the bottom itself. Velocity of sound in air at 0 degrees Celsius is 330. V proportional to square root T at 0 degrees Celsius, 73 Kelvin. Equation number 1. Now the velocity here is 348.3. Temperature we don't know. That is 273 plus theta. Equation number 2. Divide the second equation by the first equation. 348.3 divided by 330 equals 273 plus theta divided by 273 square root. Square both sides. 348.3 divided by 330 squared. 273 plus theta divided by 273. Simplify this. Theta you can get in Celsius. Theta you can get in Celsius. So if you do the basic calculation, 348.3 divided by 330 squared multiply by 273 subtract 273 31 Celsius. 31.1 Celsius. 31.1 Celsius. Okay, now? Next part. If the value of gamma is 1.403, Cp over Cv is 1.403, calculate the average molecular weight of air. You may assume air is ideal. Now you can use 0 degrees or 31.1, anything. Roman 3 is equal to V equal gamma RT over molar mass square root. V is equal to 330. Gamma is 1.403. R is 8.3. Temperature 330, 273 Kelvin, molar mass. Square root. Square both sides. 330 squared. 1.403 multiplied by 8.3 multiplied by 273 over M. M is equal to 1.403 multiplied by 8.3 multiplied by 273 over 330 squared. Simplify this, you get your answer in kilogram per mole. Kilogram per mole. If you do the simplification, you can get your answer in kilogram per mole. How much? 1.403, 8.3, 273 over 330 squared. 0.029 kilogram per mole or 29 gram per mole. Roman number 4. If the atmosphere contains amount of water vapor, would you expect the same value for the velocity of sound? Answer is no. When there is water vapor, humidity increases. When there is water vapor, humidity increases. Humidity increases, velocity of sound in air will what? Increase. Right there. When there is water vapor in the atmosphere, when there is water vapor in the atmosphere, the humidity increases. The humidity increases. When the humidity increases, velocity of sound in air will increase. When the humidity increases, the velocity of sound in air will increase. When the humidity increases, velocity of sound in air will increase. Okay, right. That concludes question A-level question 1993 A-levels. Yeah, 1993 A-levels. Right. Next one, 1994 A-levels. 1994 A-levels. Distinguish clearly between progressive waves and stationary waves for the following. So you can write progressive waves on one side. Progressive wave means traveling wave. Stationary wave means traveling wave, stationary wave. Right. A. Energy transmitted along the string. So here, energy is transmitted. Energy is transmitted. Here, no energy is transmitted. No energy is transmitted. No energy is transmitted. B. Amplitude of the points of vibration. All points vibrate with the same amplitude. Vibrate with the same amplitude. B. Inside a loop from point to point, amplitude will change. Amplitude will change. Point to point, amplitude will change. At a node, amplitude is 0. At an antinode, amplitude is maximum. Amplitude is maximum. C. Frequency of the points. All points vibrate with the same frequency. All points vibrate with the same frequency. C. Stationary waves, except for the nodes. Except for the nodes. Why? At the nodes, there is no vibration. All points vibrate. All other points. No? All other points vibrate with same frequency. Vibrate with same frequency. Okay. Right. Let's go directly to the question. A variable frequency source emitting a pure note is placed just above an open end of a uniform vertical tube. The lower end of the tube is closed, that means closed tube. Lower end of the tube is closed, therefore closed tube. 0.5 meters. If the frequency of the note emitted by the source is gradually raised from 150, at what frequencies will resonance occur? You may neglect the velocity of sound in air. So what you can do is you can write for the first harmonic. You can write for the first harmonic. You can ignore the n correction. Lambda divided by 4 is equal to 0.5 plus n correction. Neglect n correction. Therefore, lambda is equal to 2 meters. B is equal to F1 lambda. Velocity of sound in air 27 degrees 330. Lambda is 2. F1 is 165 hertz. Then third harmonic 3 times F1. 3 times 165, 15. 19, 4. Fifth harmonic, 5 times F1. 5 times 165, 25, 32, 3. 825 hertz. F, 7. Seventh harmonic. 7 times F1, 165. 35, 3, 42, 42 and 3, 45, 4. 1055 hertz. So these are your vibrational frequencies I have found for the seventh harmonic. Right. Okay. Now, first harmonic found, second harmonic, third harmonic found, fifth harmonic found, seventh harmonic found. Right. The air temperature is now changed. It is found that the frequency of the note emitted by the source is increased, and resonance first occurs at 168. So frequency is increased, resonance will first occur at 168. Frequency is NV divided by 4 times L plus N correction. Frequency is frequency is increased. Now fundamental frequency is higher. Fundamental frequency is higher. We are looking at this logic. F is equal to NV over 4 times L plus N correction. At this harmonic number of the tube is the same. N correction same. Frequency is proportional to velocity. They are telling you here, if the experiment is repeated with the lower end of the tube open, corresponding situation, that means harmonic is 335. Right. Okay. So frequency, temperature has changed, velocity has changed. Therefore, temperature has changed, velocity has changed, frequency has changed. Technically, fundamental frequency 168. Frequency has increased, that means velocity has increased, that means what? Temperature has increased. Fundamental frequency 165 became 168 means frequency has increased, velocity has increased, therefore temperature has increased. Right. So they are telling you something interesting. Fundamental or whatever the harmonic, resonance first occurs at 168. Corresponding situation means fundamental harmonic of the open tube as well. Again read. Air temperature is now changed. It is found that the frequency of the note emitted in the resonance first fundamental frequency is 168. If fundamental frequency increases, velocity will increase. Velocity will increase, temperature will increase. Okay, now? Right. The experiment is repeated with the lower end open for the corresponding situation. Corresponding means what? Fundamental mode. Then the frequency is 335. Right. Now let's work this carefully. Tube is there. 0.5 meters. Fundamental mode of vibration 168 hertz. Now both ends of the tube are open. Corresponding situation means fundamental mode. N corrections are there on both sides. 0.5 meters. Frequency is 335 hertz. Right. Carefully apply. Lambda divided by 4 is 0.5 plus N correction. Lambda is 4 times 0.5 plus N correction. V is equal to F lambda, new velocity. Frequency is 168. Lambda is 4 times 0.5 plus N correction. Here, quarter, half. Lambda divided by 2 is 0.5 plus 2 N corrections. Lambda is 2 times 0.5 plus 2 N corrections. V is equal to F lambda. There you go. Velocity of sound in air, we don't know. Frequency fundamental 335. 2 times 0.5 plus 2 N corrections. Open brackets. 0, 6, 7. There you go. 2. Equation number 2. So what can you say? 1 and 2 are equal, no? Equate it. You can find the end correction, speed of sound, and the new temperature, right? Simplify it. 168 multiplied by 4.5 plus end correction. 335. Sorry. 670. 670.5 plus 2 end corrections. Right. 32, 3, 20C, 27, 6. 0.5 plus n correction. 670.5 plus 2 n corrections. Simplified 3, 3, 6. 672 n correction. 3, 3, 5 plus 1340 n correction. Simplify 336 minus 335 is 1. 1340 n correction minus 672 n correction. 1340, 672. 668 n correction. 1 over 668 meters. From this, you can get your answer at least for 2 decimal or a particular significant number because they'll give you marks for that. Point 0015. 0.0015. N correction found. Once you find the n correction, now you can substitute to any equation you want. Substitute to, let's say, equation 1, get the velocity of sound. 168.4, 672.5 plus n correction 0.0015. Velocity of sound in air at least for 1 decimal place. It's a simple work, huh? Not complicated work. (337). 330 meters per second. So Roman 1, I have found the answer. Roman 2, I have found the answer velocity. Finally, find the new temperature. How do you find the new temperature? V proportional to square root T. What have they given you? 330, 20 second, 300 Kelvin. Now 337 velocity. What is the temperature? Equation 2. Divide the second equation by the first. 337 divided by 330 equals square root T1 over 300. Square both sides. 337 divided by 330 whole thing squared. T1 divided by 300 square root or cross multiply. 337 divided by 330 whole thing squared multiplied by 300, you can get the temperature. So how will you get the temperature here? Simplify it. 337 divided by 330 squared multiply by 300. 312.86. 312.9 Kelvin. If you take in Celsius, how much? 300.9, 273. 39.9 Celsius. 39.9 Celsius. Okay. 39.9 Celsius. Okay, no? So there basic calculation, you can get the answer. Basic calculation, you can get the answer. So they want the temperature there. From the temperature, you can get the answer. 337 divided by 330 squared multiplied by 300. 312.8, 312.9, 330 approximately. 39.9 or 40 approximately. One of the two. So right now. So look at the question. This is 1994 A-level question. Progressive waves or traveling waves, stationary waves. For different energy, amplitude, frequency, we have analyzed the condition. Then they are telling you closed tube 0.5 meter, possible resonant frequencies, neglecting N correction. 165, 495, 825, 1055, continues like this. It is odd multiples of the fundamental mode. Then the logic is, they are telling you, now same harmonic, same harmonic, same harmonic, length is same, N correction same, frequency higher means velocity higher, velocity higher means temperature is higher, guaranteed temperature is increase. Then what we can do is, closed tube fundamental mode 168, simplify, get the relationship. Same harmonic, open tube, you can get the relationship. Both are vibrated with the same frequency, the velocities are same. Velocities are same, sorry. Equate, get the N correction, get the velocity. Get the velocity. Right? Okay. Right. Next is 1995 A-level question. 1995 A-level question. Once the N correction is neglected, resonant frequencies can be written as F equal NV divided by 4L. Okay. Where N is going to be odd numbers 1, 3, 5, 7. Okay. Continues. Similarly, when the pipes are open, this is closed pipe, closed tube. This is open tube. Open tube frequencies are N dash V divided by 2L. N dash harmonic numbers are 1, 2, 3, 4. All harmonics are there. Right. Question number 1. Roman 1. In both cases, show that the above formula is true for the fundamental and the first overtone. Right. You must draw. They give marks for this. Fundamental mode of vibration. Lambda divided by 4, L plus N correction. Ignore N correction. Lambda divided by 4 is L. Lambda is 4L. If lambda is 4L, V equals F lambda. F is equal to V divided by 4L. You can write here similarly. When N is equal to 1, F equal V over 4L. F equal V over 4L. This is your first harmonic or fundamental mode. Or we can say fundamental mode. Fundamental mode, okay, no? Right. Then you can do it for the first overtone. First overtone. First overtone is third harmonic. Here you go. Incorrection here lambda. Half and quarter, 3/4. 3/4 over lambda L plus incorrection. Ignore the incorrection. Lambda is 4L over 3. B is equal to F3 lambda. 4L divided by 3. F3 is 3V over 4L. Right. Similarly, N equal 3. F equal 3V over 4L. N equal 3. 3V over 4L. Okay, no? Problem solved. So when N equal 1, I get the same answer. N equal 3, I get the same answer. Done. For closed tube. What about for open tube? For open tube, both ends open. Fundamental mode. Incorrection is there, L. Quarter, half. Lambda divided by 2. L plus 2E. Ignore incorrection. Lambda divided by 2 is L. Lambda equal 2L. V equal F lambda. From this you can say F is equal to V over 2L. Now from the equation. Similarly, when N is equal to 1, F is equal to 1V over 2L. Same answer I will get. This is at the first harmonic or fundamental mode. First harmonic or fundamental mode. Next one is first overtone. First overtone. If you carefully draw the first overtone here, then tell. Quarter, half. Lambda is L plus 2E. Lambda is L plus 2E. V is equal to F lambda. L plus 2E. F is V divided by L plus 2E. First overtone. Similarly, from the equation, when N is equal to 2, 2V over 2L. Ignore incorrection. Ignore incorrection. Lambda equal L. V over L. So when N equal 2 also I can get the equation. Right. So right now, basic work. Using fundamental, I have proved the equation. If I substitute for the equation also, I get the same answer. Same answer. Using fundamental process, I have got the answer. If I substitute for the equation also, I get the same answer, right? Roman 2 now. Roman 2. Now what? A uniform pipe closed at one end resonates at frequency 210. One end closed, 210. Both ends open, 840. Do we know the harmonic number? No. Neglecting n corrections, calculate the minimum length of the pipe which satisfies the condition. Right. Closed tube. F equal NV over 4L. 210 hertz. NV don't know. V 4L. Equation 1. Open pipe. 840 or F dash equals N dash V over 2L. 840 N dash V over 2 times L. Equation 2. What can you do? Divide one equation by the other. Common terms will cancel. 210 divided by 840 is same as we did earlier. You're finding the ratio of the harmonic numbers. NV over 4L divided by N dash V over 2L. 1:4. VV LL cancel off. N over N dash half. 2 cancel off. N over N dash is half. They're asking the minimum length. Therefore, N is first harmonic. N is first harmonic. N dash is second harmonic. Harmonic number we are talking. What are they asking you? Minimum length of the pipe. Substitute to equation 1 or 2, whatever. 210. N is first harmonic. Velocity of sound in air 340 over 4L. L equal 340 divided by 840. 34 over 84, that is going to be meters. 34 divided by 84. 0.404. Right. Minimum length. Under these conditions, what does 210, 840 correspond to? 210 hertz. First harmonic, don't forget. First harmonic. 840 hertz. Don't forget. Second harmonic. I have proved the relationship. Okay. Right, there you go. So vibration in tubes, the difficult, those all past papers I gave, I have discussed and finished. So the questions I discussed are 1990 A levels. Look at the connection. They are giving you closed tube vibrates with this frequency at 2 different lengths. Now remember, when we are comparing the harmonics, ignore the n corrections and work. 1:3. Look at this question, Vilu. Here also, they have already told you ignore the n corrections. When you are comparing the harmonics, you can get first harmonic, second harmonic. Is it clear? Okay. Right. So that concludes the helpline discussion for the old past papers for vibration in tubes. See you next time with another episode or another what you call helpline, and we discuss more questions. Keep studying, keep working, and day to day you will improve gradually, slowly and steadily.